So I think I want to finish this problem, just to kind of show you all the math here a little bit. So for all of these problems, my first step, my first thought is, what type of a problem is this? So if you see a current flowing, if you see something about plane B appears to the people in plane A, or, you know, the car relative to the train, or something with respect to, then you know it's a relative velocity problem. Now, I think y'all have it easy, though. You're going to know that the last problem on your test is a relative velocity problem. So once you know that, then I think the next step is, okay, do I need A/B or B/A or C/T? You know, so read the problem statement and figure out what you need. If it's one of these where it's a current problem, then the current goes in this spot, and so it's kind of the denominator of the something / current. So then write that equation. I like to write it this way, you know, VA plus VB plus VA/B. And then real perceived. And then just plug in everything you can and solve for what you need to. All right, so with this one that we left off, VB, I don't know the real velocity of B, but I know it is really going along this line right here, right? Now he's aiming somewhere else, but he's really going along that line. And that we could figure out using tangent of 50 over 25 is a 63. So I'm going to put cosine 63.4 in the I and VB sine 63.4 in the J. So if you don't know its magnitude, but do know its angle, go ahead and plug in its angle. Go ahead and do sine and cosine. All right. Then on the right-hand side, the river is really going at 2, and it's all of it's in the I. Don't have to worry about sine or cosine. It's all horizontal. And then this other one, the perceived, he feels his arms, the rowing feels like it's going at 5. So that's 5. And then what he feels like he's aiming, that's theta. So 5 cosine theta in the I, 5 sine theta in the J. Now this one equation has 2 unknowns, but it's okay because it's really 2 equations, I equation and J equation. You'd think this would be easy to solve, but let's see what happens. VB cosine 63.4 on then I've got 2, and then I've got 5 cosine theta. That one equation has 2 unknowns, so let me jump to the next one. VB sine 63.4, and this is 5 sine theta. 2 equations, 2 unknowns, should be able to solve for it. Now sometimes, and especially if we didn't have that 2, then we could solve this, and you know that a sine over a cosine is a tangent. And so that's the only thing you have to know if there wasn't a 2 right there. And so I'd expect you to be able to handle a problem like this. If there was no constant, you would just write 1 in terms of the other, and then eventually you'd have like a sine over cosine is equal to a tangent. But this one, this is my instinct. I wish I had some numbers here for you, but I would divide the sine 63.4 over, and 5 divided by sine 63.4. I don't have that, but it's just a number, sine theta, right? 2 equations. How I like to solve 2 equations, write 1 in terms of the other, plug it in. So I'd write VB in terms of theta. So I'm just going to put number. Maybe I should actually, so then I'm going to plug that in and multiply it times cosine 63.4. And so still, I would have, it would be a different number, but I'd have something sine theta equals 2 plus 5 cosine theta. 1 equation, 1 unknown. Seems easy. Unless there's an easier way to solve this problem, which there possibly, if we drew vectors tip to tail, use law of cosines, that might be an option. But I know I've got this equation right here that I can, out in my back pocket, that I can use. So A sine theta plus B cosine theta if I wanted to group those together into one term, which is kind of what I do, I kind of want to group this one and this one. So I need to put them on the same side of the equation. So it might be -5 cosine theta, right? Something sine theta minus 5 cosine theta equals 2. I can group those together, and the answer would be a squared plus b squared square root. So this number squared plus minus -5 squared, take the square root, times sine phi. So this is a different angle, but that's what I would do, and I would solve for phi. So I'd do that, I'd solve for phi, and then I've got another equation. Phi is theta plus inverse tangent b over a. So once I've got an angle, phi, maybe it's 94.7 degrees, then I would subtract the inverse tangent b over a. You might need that equation for your homework. You won't need that equation for the test. For the test, I will expect you to know that sine over cosine is tangent. So that's how you can solve for those sometimes. Okay, do you want the final answer? I've got VB is 5.56 meters per second. That's his real velocity. That's velocity he's really going. And theta is 84.4. Theta, it goes up here with a relative term. All right, so does it make sense that he's going 5.56? He can row in still water at 5, but the river is pushing him downstream, and so he's really going at 5.56 at this angle. And also, does this make sense, 84.4? If he wants to go 63.4, if he wants to really go 63.4, he had to aim at 84.4. He had to aim at 84.4. All right, so there is another option. I'm not going to try, but there is an option of adding vectors. Here's VB slash R, right? Here's VB. Here's VR. Is it true that VB is equal to VR and VB slash R added together? And so if you do it with vectors, you might use a different equation and not have to use my trig kind of identity. So there's that. The main thing, though, this problem, putting the right angles with the right terms, right? Real, perceived. All right, let's